When the ammonium hydroxide is introduced, the reaction causes the bright yellow precipitate, known as yellowcake, to form and settle. The rotating drum filter separates the liquid, allowing a precision blade to scrape off the dense yellowcake paste in a continuous ribbon.
Pressure looks stable now. Maintaining the feed rate at 200 kilograms per hour.
Yellowcake uranium powder is dissolved in nitric acid to create uranyl nitrate. The liquid glows with a faint neon green hue inside the glass-lined reaction vessel.
Check the flow rate on H2
Confirmed. Running stable at 150 kilograms per hour.
Utilizing high-tech magnetic bearings, the centrifuge rotor spins in a vacuum, completely free of friction.
Shiny silver pipes carry enriched uranium to the next stage, while depleted uranium is sent to the tails, clearly marked by the blue and orange stripes. Depleted uranium hexafluoride, the byproduct, is collected in massive 14-ton cylinders.
But the enrichment level at the final stage is fluctuating.
We are adjusting the feed rate now. It should stabilize shortly.
Field confirmed, all parameters green.
Data logged, moving to the next cylinder.
Yes, let's proceed.
The large V-shaped blenders rotate slowly to ensure the enriched uranium powder has a uniform isotopic distribution. Small amounts of binding agents are added to the uranium powder. A robotic arm dispenses the additives with sub-milligram precision.
The sintered pellets are precision ground by a diamond-encrusted wheel. As the coolant sprays, sparks fly from the uranium dioxide.
The laser precisely scans each pellet for imperfections. Any defective pieces are immediately ejected into the recycling bin by the automated arm. A small stainless steel spring is placed at the top of the uranium pellets to keep them in place during reactor operation.
The sealed uranium fuel rod is placed in a vacuum chamber to ensure the weld is airtight. If helium escapes, the rod is rejected.